All right. I had given a set of problems that I said to be looking into, and just for practice purposes. And we looked at multiplying polynomials as well as factoring them. And we looked at, toward the end of the first class, the factoring by grouping. And for what we have on page 41, okay, this is going to be, in a way, a case of factoring by grouping, where you have four terms already laid out as opposed to having a single term in the middle to split up into two terms in the same variable. And here we have four terms laid out, and we have, instead of just one variable, we have a couple of letters with A and X. And if we take what we have from this group, okay, now the coefficients and the variables are such that we can perform factoring by grouping, okay, because you have with the first two terms, you have like an 18 to 8 or 9 to 4 ratio, and between the last and the third coefficients, you have like 45 to 20, which is a 9 to 4 ratio as well. And in other words, had the last number been something like 47, I would not be able to perform factoring by grouping. But since I had the coefficients and the variables in proportion as they are laid out, I'm able to group into pairs. Okay, so we have for this particular situation, okay, so if I group into pairs, okay, what we have at the start, okay, so we have 8ax plus 18a, okay, and we have the operation in the middle, separating the first two apart from the last two terms. Okay, we have to be addition. Okay, so you have the quantity of 20x plus 45. And we have in the next stage, okay, so we're looking at drawing out the greatest common factor. And for the first two terms, now both of these contain the letter A, and along with A, we have the highest coefficient that will go into both 8 and 18, which is going to be 2. Thus, we have the greatest common factor is going to be at 2a. So we have 2a into 8ax, which will be 4x. And we have 2a into 18a is going to be at 9. And upon bringing down the subtraction, now we have the greatest common factor of 20x and 45, and this particular greatest common factor is going to be at 5. And taking into 20x plus 45, okay, we're going to have the quantity 4x plus 9. And so for the factorization, okay, we have with the groups, okay, we have 4x plus 9 as a common factor. And the other part of the solution will come from the outside terms in operation, that is the respective greatest common factors and the operation that was initially in the middle. So we have 2a and plus 5, and this will be the other combination. So this quartet will factor out to the quantity of 4x plus 9 times the quantity of 2a plus 5. Okay. And now, for what we have in the case of number 87, okay, and there's going to be a bit more work that is going to be involved. And for what we have here, okay, we have terms in the letters y and z. So we have 7y cubed z minus 40y squared z squared. We have minus 12yz cubed. Okay, now from the first class, okay, we looked at just going ahead and factoring the polynomials into binomial expressions. And I'm going to do a bit of gear shifting. We're still going to factor out binomial expressions, but here for what we have in the process, we're going to factor out, just like what we did with the greatest common factors here. We're going to take an overarching greatest common factor among these terms. Notice they all have the letters Y and Z shared in common. So we're going to take out what is referred to as the greatest common factor. And that is only going to be Y and Z, or Y times Z. So for what we're going to have in the mix, so we have the greatest common factor at YZ. And for what we have in the process, okay, so we got YZ into this trinomial. Okay, so this will be 7y squared minus 40yz minus 12z squared Okay, so we got yz as part of the solution, and the other portion will stem from factoring out, okay, this newly established trinomial factor. Okay, so we have in the process, okay, we'll be able to factor by grouping. And we have different letters involved. Okay, in fact, we have two letters as opposed to just, say, the letter X. And with the degrees of the variables, we'll be able to perform factoring by grouping. So for what we have in the mix, okay, we're still going to be looking at performing factoring by grouping. Okay, so we have starting out, okay, just like factoring by grouping, you initiate the process by multiplying the first and the last coefficients. So again, we have 7 times negative 12 and 7 times negative 12. Okay, so this will be at negative 84. And for what we will have in turn, now we're looking at factors of negative 84 that will add up to negative 40. Okay, so for what we have here, just to sort of restate, okay, so you had 7 times negative 12, which is negative 84, and if I were to add together, I would come out to negative 5. But I'm looking for where the sum is going to be at negative 40. Okay, so, and in this particular case, all right, we're going to have, for these factors, more weight will be given to the subtraction than to the addition, or to the negative factor than to the positive. Okay, so you have negative 42 times 2 is negative 84, and negative 42 times 2, okay, that will be negative 40. And I'll just rewrite what I have here. And for what I have with this particular trinomial factor, okay, so for what we have in the process, so the negative 42 and the 2 will split the negative 40 that is situated in the middle. And so we're going to, it doesn't matter what order you place these, but I say if you have a negative and a positive factor, I like to have the operation of addition in the middle, so I'm going to have the 2 to follow the negative 42. And thus we have here, okay, entering the stage of factoring by grouping. And for the grouping, okay, we have with the first two terms, so we have 7y squared minus 42yz. And we have the operation of addition in the middle. So you have the quantity of 2yz minus 12z squared. And taking what we have in the next phase. Okay, so greatest common factor, the first two terms, you have 7 and y. And into the first pair, so 7y into 7y squared minus 42yz. Okay, that is going to be y minus 6z. And bringing down the plus. Okay, now we have with the greatest common factor of the second pair, so that's going to be 2 times z. And taking into the last two terms, and we're also going to have y minus 6z so between the groups, okay, we have a shared common factor with y minus 6z, and the other factor will stem from, again, the greatest common factors and the uniting operation, which is going to be addition. Okay, so this will be the factors that will result from, okay, this trinomial. But now for what we have in the overall picture, okay, going back to our original problem, so we had drawn out the greatest common factor. With y times z, and again for the factorization of the trinomial. Okay, so you have for the other portions that will make up the solution. Say again, we have the quantity of y minus 6z. And we have times that of 7y plus 2z. All right, quite a few steps involved in this one. Okay, and but for number 87, so for the complete factorization, okay, we do have 3 factors in the mix. Okay, so you have p squared plus 8p plus 16. Okay, so have just a single variable. And starting out with the trinomial, okay, and this one we can factor right away. So just like x squared factors out to x and x, okay, p squared will do the same thing where we have first order terms in p. And factors of 16 that will add up to the middle coefficient 8. Okay, those would be both positive 4. And since we have repetition of p plus 4, okay, we can condense the result here to the square of p plus 4. All right, much quicker problem to work through than what we had in number 87. Now, for what we have in the case of kind of going back to ramping up the intensity, and we have with number 91, okay, so we have in this one, and this is going to be sort of a hybrid of what we have with number 87 and number 90, at least in context. And for what we have in number 91, okay, so we have, looks like we have the terms, have 50x cubed, plus 160x squared y, and we have plus 128xy squared. And just like how we started out with number 87, okay, there's a greatest common factor to pull out, okay, before we even factor out any binomial expressions. So we have for the greatest common factor, now we have even numbers throughout for the coefficients, okay, and so into 50, 160, and 128, okay, we have 2, and then all of x cubed, x squared, y, xy squared will have only x in common. So the greatest common factor is going to be at 2x. And then taking into the trinomial, okay, so you have 25x squared, and we have plus 80xy. Then we have 64 y squared. Okay, so just for the setup, okay, now we're going to have a trinomial to factor. And this is yet another one that we can perform factoring by grouping. So for what we have here, again, we have variables in x and y. Okay, now we're going to have if you were to factor, okay, your first terms will consider first order in x, last terms will consider last terms in y, and then if you're to FOIL out, your outside and inside products would end up with the letters x and y, both of which would be a first degree. Alright, so we can factor by grouping here. And again, just taking the first and the last coefficients. So you have 25 times 64. Okay, so that is going to be at 1600. And again, we're going to be looking at factors of 1600 that will add up to 80. And 1600, rather large number. Okay, so for what we have, again, just to sort of restate, we dealt with 25 and 64. Again, those numbers will add up. Instead of to 80, we have 89. And in terms of, now 1600 has a lot of factors, but the combination where the sum is going to be at 80, we're going to have the factors to be both at 40. So in taking what we have now, so we have with 40 and 40, we're going to split up the 80xy term into 40xy plus 40xy. Okay, so you're going to have the middle operation as addition. Okay, all the terms are positive throughout. And so we have, upon looking at grouping, Again, the first two terms, you have 25x squared plus 40xy. And you have plus the quantity. Okay, you have 40xy plus 64y squared. And so just looking at what we have for the factors, okay, that which will go to 25x squared plus 40xy. Okay, greatest common factor, so that is going to be 5 times x. And 5x into the first pair, this will be 5x plus 8y. Yeah, plus, and 40xy plus 64y squared. Okay, now the greatest common factor, that will be 8y. And into 40xy plus 64y squared, so we're going to have another 5x plus 8y. So for the shared factor, we have 5x plus 8y. And it's going to turn out that for the outside terms combining, we also have another 5x plus 8y. So we're going to have altogether, we're going to have the square of 5x plus 8y. And so for what will end up in the result is that for the overall solution, okay, so for the given trinomial, okay, we have 2x is already factored out. And then for the complete factorization along with 2x, again, we're going to have the square of 5x plus 8y. Again, the process does get to be a bit tedious, and much of that is the fact we have raised coefficients, and also more than just one variable, and also where you have factoring by grouping, and again, thanks to those raised coefficients. All right. Now, in the case of what we have for number 94, okay, and this one kind of a continuation, but not one that you had to pull out a greatest common factor, as was the case with 87 and 91, but we do have in 94. And we have higher degrees this time around. Okay, so you have in the letters m and n, so you have 9m to the 4th plus 42m squared into the 4th. Then we have plus 49 into the 8th. And again, greatest common factor out of this trio would be just the number 1, because while we had the letters m and n involved, well, m is present only in the first two terms, and n is only with the second and last terms. Okay, so there's no common variable factor throughout. And again, for 9, 42, and 49, greatest common factor is only 1. Okay, and so if we look at this trinomial, now we can factor by grouping. Okay, so again, starting out with the first and last coefficients. So you have 9 and 49, and 9 times 49. Okay, that will be 441. And looking for the factors of 441, that will add up to 42. And there's going to be a bit of history to repeat. Just like 1600 was a perfect square number, well, 441 is also a perfect square. Again, we had 9 and 49. Some we have at 58. And now to add up to 42, and also multiply out to 441, okay, we're going to have, again, identical terms. This time with 21 and 21. Okay, so looking at splitting up the middle term, which will consist of the square of m and the fourth order of n. Alright, so you have 9m to the fourth plus 21m squared n to the fourth plus 21m squared n to the fourth plus 49 n to the eighth. Okay, and so we are in the realm of factoring by grouping. Okay, so we have with the first two terms, okay, we have 9m to the fourth plus 21m squared n to the fourth and again we have the operation in the middle to be addition. And just quantifying the last two terms in parentheses. Okay, so looking at the greatest common factors, now we have with the first two terms. Okay, now 3 will go into 9 and 21, and both terms have the letter m in common. Okay, and so the greatest common factor we have to be 3 times the lesser of the appearance in the degree for m, so that's going to be m squared. So the greatest common factor we're going to have it 3m squared. Let's go into the first two terms. Okay, so we have 3m squared, and we have plus 7 n to the fourth. And we have breaking down the addition. Okay, and we have greatest common factor. Okay, so 7 will go into both 21 and 49. And between the variables, okay, we have the letter n shared in common, and that which will go into both of these terms, we have the lesser degree appearance in n, which is going to be to the fourth power. And we have also factoring out, so we have 3m squared plus 7 times n to the fourth So again, for that which is shared in common, you have 3m squared plus 7 n to the fourth, and packaging together the greatest common factors and outside operation, turns out that we have another 3m squared plus 7 n to the fourth. So this binomial repeats. And so it turns out that what we have in number 94, okay, is a square trinomial. Okay, and so we have, for the result, we have the square of the quantity of 3m squared plus 7 n to the fourth. Now, for what we have in the next phase, and this is what we're going to have with what will be regarded as sums and differences of cubes. And we're just going to touch upon this lightly, and it will reappear once we get into the second half of the course, where we're going to have sections that will involve polynomial and synthetic division, and some of the material in the mix will involve like sums and differences of squares, as well as, again, sums and differences of cubes. Okay, so for what we have at the foundation, okay, for sums and differences of cubes, you do have a formula. Okay, now for the sum of cubes, so you have a to the third plus b to the third. And if we factor out, now there's going to be a binomial factor of addition, whereupon we're going to have the quantity of a plus b. And there's going to be a trinomial factor where we're going to have an operation of subtraction of the middle term. In this case, we're going to have a squared minus ab plus b squared. Okay, and we have on the side of the sums and differences of cubes, say if I take, as an example, if I have something like x cubed plus 64. Okay, now x cubed is a perfect cube. 64 is also a perfect cube. And if I write 64 as the cube of a value, so we have with 64 now, 64 is the square of 8, since 8 times 8 is 64. And 64 is not only a perfect square, it is also a perfect cube, because there is a number times itself that will come out to 64, and that number is 4. Okay, so we have x cubed plus 64, so we have x to the third plus 4 to the third. So here you can look at this as where we have a represented by x and b represented by 4. If I were to take to heart what I have with this algorithm, say we have with a plus b, that's going to be represented by x plus 4. And we have times the quantity. Okay, so we have a squared becomes x squared. And we have minus a times b, so this will be minus x times 4. If you see the result already in advance, okay, that's fine. And then we have plus b squared. Again, b is going to be represented by 4, so b squared becomes 4 squared. So this will come out to the quantity of x plus 4 times that of x squared minus 4x plus 16. Okay, and if you're to multiply these sets of terms together, your result will come out to x cubed plus 64. And we will be looking again into polynomial multiplication and division, especially if you have going outside the realm of binomial expressions. Now, for what we have in the case of the difference of cubes, so we have with a cubed minus b cubed, now we're going to have the first order factor, in this case the two-term expression, is going to be the binomial, okay, where we have the quantity of a minus b. And here we have the quantity of a squared plus ab plus b squared. And just taking as an example of a difference of cubes, let's say if I have something that has a raised coefficient, so we'll say that we have something like 27x cubed, and we'll say we have minus we say have minus 8y cubed. So I'm going to just treat these with raised coefficients. So we have 27x cubed. That is a perfect cube. X cubed is the cube of x. Now 27 is going to be the cube of 3. Since 3 times 3 times 3 is 27. So this first term is going to end up as the cube of 3x. And for 8y cubed, y to the third is the cube of y. Now 8 is going to be the cube of 2. So 8y cubed is going to be the cube of 2y. So for what we have here in this layout, so A is represented by 3x, B by 2y. And if I were to say in focus, now that represents A and B. Carrying over to what we had to represent A minus B, this will become 3x minus 2y. And representing A squared, okay, so we're looking at the square of 3x. And we have plus A times B, so A we have at 3x, B we have at 2y. And for B squared, we have 2y quantity squared. And for this end result, so we have the quantity of 3x minus 2y. And then we have square of 3x. Again, that's going to be 3x times 3x. So this will be 9x squared. 3x times 2y. So this would be 6xy. And for 2y quantity squared, or 2y times itself, this will end up at 4y squared. And that would be the resulting trinomial factors. So for this difference of cubes, okay, these are your factors. All right. And now, for what we have in 102 and 106, okay, so we do have sums and differences of cubes. And for 102, okay, we have with the sum of cubes. This time we have the letter u involved, so you have u to the third plus 343 okay, so u to the third, okay, that's the cube of u once again. Now for 343, perhaps not a number that you see very often, but it happens to be a perfect cube, and that's going to be 7 times 7 times 7. So you have the cube of 7. Okay. And just taking what we have here with the sum of cubes. Okay, so you have a plus b is represented by u plus 7. And for a squared, we have u squared minus ab, so you have minus the product of u and 7. And you can just go ahead and write that as 7u minus 7u. And for plus b squared, so you have plus 7 squared. And for what we have in the follow-through case, we have the quantity of u plus 7 times that of u squared minus 7u plus 49. Now, in the case of what we have with 106, okay, so you have another sampling of a difference of cubes. Okay, but we have on display, we have degrees outside of third order in the variables. Okay, so we have 27 m to the 12th. Then we have minus 64 n to the 9th. So we have this one, okay, so we have a difference of cubes, okay, and in terms of, if we write in terms of a cubed minus b cubed, so in a way we're going to be looking at taking the cubic roots of each of these terms, okay, and there's a bit of power property of exponents concentration that will be involved. Okay, so for 27 m to the 12th, okay, we have like the cubic root of 27, that is at 3. And that times itself will give you m to the 12th. That is going to be m to the 4th. Okay, like 3 cubed is 27. M to the 4th to the 3rd, that would be m to the 4th times 3, which would be 12. So the a is going to be represented by 3 times m to the 4th. And looking at what we're going to have for b. Now for 64, n to the 9th. Okay, now the cubic root of 64 is 4. That of n to the 9th is going to become n cubed. So I've got 4 cubed is 64. N to the 3rd cubed, that's n to the 3 times 3, which would be n to the 9th. So we have a at 3m to the 4th, b at 4n cubed. And just taking what we have in the setup for a minus b. We have 3m to the 4th minus 4n cubed. And for the a squared, we have the square of 3m to the 4th. We have plus ab, so we're looking at multiplying 3m to the 4th. And 4n cubed. And we have plus the square of b, which would be plus the square of 4n cubed. Okay, the terms are getting to be a bit crowded, but we're going to sort of clean things up here. So we still have, with the binomial factor, we have 3m to the 4th minus 4n cubed. And then we have for the trinomial, so the square of 3m to the 4th, 3 squared is 9. For the m to the 4th squared, that's m to the 4 times 2. So that's going to be at m to the 8th. And then for that which represents AB, you have 3 times 4 is 12. Then we have m to the 4th, n to the 3rd. And for b squared, that is going to end up at 4 squared, which is 16. N cubed squared is going to end up at n to the 6th. Okay, so we have for the final result, okay, we have 3m to the 4th minus 4n cubed times the quantity of 9m to the 8th plus 12m to the 4th n cubed plus 16 n to the 6th. Now, in looking at what we have working with expressions, okay, so we've been looking at multiplying and factoring polynomial expressions. Okay, now I'm going to a little bit of a different direction. Okay, instead of dealing with direct polynomials, we're going to just kind of make a segue over to rational expressions. And some of the commonalities would be stuff like least common multiple and greatest common factor. And in the case of rational expressions and operations, okay, say we have just a little sampling. Okay, if you're looking at adding together fractions And say we have just with numbers. Okay, so we have something like 3/4 plus 7/8. And I want to combine these fractions together. Okay, and of course you're not going to add the numerators and denominators, okay, as they are laid out. But to be able to add fractions, okay, we need the bottom part to be the same. And between 4 and 8, okay, we have the least common denominator is already present in the second ratio with the number 8. And if I were to adjust the 3/4 into 8s, okay, so you got 3/4 plus 7/8. And if I adjust the 3/4 and make this into 8s, what I'm going to do here is I can multiply 3/4 by 1. 3/4 times 1 is still 3/4. But if I write in terms of 8s, what I'm going to do here is that for 3/4, okay, so if I raise 4 to 8, 4 will go into 8 2 times. So I'm going to multiply 3/4 by 1 in the form of 2 halves. And the reason for that again is that 4 will go into 8 2 times. So I had the capacity of raising the 3/4 in terms of 8s, and I'm still multiplying by 1, which still preserves the value overall of 3/4. So just looking at what we have now, 3 times 2 is 6, 4 times 2 is 8. So I have 6/8 plus 7/8, and combining fractions. Now that we have the same denominator, 8, only thing I have to do now is just to combine the numerators or top parts of the fraction. So we have 6 plus 7 is 13, and so we have for the overall sum, okay, that is going to be at 13/8. And you can leave it as a fraction or as a mixed number like 1 and 5/8, or I think even Alex would allow a decimal if it terminates. In this case, that would be 1.625, I believe. Yeah. And let's say if we have letters involved. Okay, let's say if we have 5 over 2x squared y. Then we have plus 3 over 4xy squared. Now for the least common denominator, okay, we don't have the same bottom parts in the ratios, okay, but if we adjust, okay, so you have for 2 and 4, the smallest number that both 2 and 4 will go into is going to be 4. And for both x squared and x, okay, now the greatest common factor, you're pulling out the smaller degree. Least common multiple, you're taking the higher power. Okay, and so for x squared and x, okay, so you have x squared, and in y, you have y and y squared. So you have least common denominator. Okay, it's going to be 4x squared y squared. So adjusting what we have in the ratios. Okay, so you have 5 over 2x squared y. Okay, so I'm going to raise this ratio, multiplying by 1, and in terms of the number of times 2x squared y, we're going to least common denominator, so you have 2 into 4 is 2. We already have x squared present, and then we have y into y squared, leaves a factor of y. And now we have 3 over 4xy squared. Okay, we already have the 4 will go into itself. One time x and x squared will go x times. And y squared is already present. And so just taking what we have now, again, so you want to have both denominators, so be it 4x squared y squared. And for taking the product of the numerators, okay, so you have 5 times 2y, so this will become 10y. You got plus, and you have 3 times x, so you have 3x. And so we have in the result, you can say we have 10y plus 3x. All over 4x squared y squared. And if you were to care to put what we have in alphabetical order, okay, so you have 3x plus 10y all over 4x squared y squared. All right, and tell you what, just for what we have in the case of working with ratios. You can try out the following. And we'll say we have, in terms of fairly basic ratios, okay, so we have 3/10 minus 2/5. And we have second, okay, so you have 5 over 2xy squared. And so you have plus 7 over x squared y. And then we'll have in the mix, and this one kind of tricky. And we'll say we have 3 over 8x cubed y squared. And say we have plus 1 over 24xy. And say we have plus 3 over 27x to the 4th, y to the 3rd. Okay, tell you what, some of you might still be working on these items, and that's okay. But if we go ahead and look at these exercises, now we have for the first one, okay, we have the difference between 3/10 and 2/5, and for these fractions, okay, the least common denominator, okay, is already present. Okay. So between 10 and 5, okay, so least common denominator is going to be at 10, okay, and that is already contained by 3/10. And for 2/5 or minus 2/5, I'm going to make an adjustment. So I'm going to raise from 2/5 to its equivalent in tenths. Okay, so for 2/5, 5 will go into 10 2 times. So I'm going to multiply 2/5 by 2 halves. So we have 3/10 from the start. We have minus, and we have 2/5 times 2 halves, so it'll be 4/10. And so for 3/10 minus 2/5, that translates out to 3/10 minus 4/10. And so for the difference, this will be minus 1/10. So you have a negative result in problem number 1. Okay, now for the second item, okay, so we're looking at the difference going from the difference in fractions in number one to where we have the sum of fractions, okay, that consists of variable factors in the denominator. Okay, so we have 5 over 2xy squared plus 7 over x squared y. Now for the least common denominator, okay, so that's going to be 2. Then we have x and x squared, so we have x squared. And then the higher order in y, we have y squared. So least common denominator, we have 2x squared, y squared. And so for both of these ratios, adjustments will have to be made. And in the case of 5 over 2xy squared, okay, so you have 2xy squared into 2x squared y squared. We already had the 2. X will go into x squared x times. Y squared is already present. So the first ratio had to be multiplied by 1 in the form of x over x in order to raise the denominator, where we have inclusive of the second degree in x. And for 7 over x squared y, and taking x squared y into 2x squared y squared. So you have 2. We already have the x squared. Now we have y into y squared goes y times. And it's by there we can go ahead and cluster together what we have here. So we got in the denominator for both fractions, we have 2x squared y squared. And combining what we have here, so we got first numerator, we have at 5x. And we have with the second numerator, we have 7 times 2y, so that's going to be a plus 14y. And so we have, for the result, we have 5x plus 14y all over 2x squared y squared. Now, for what we have in the case of the last set, okay, and there are various approaches that can be taken, okay, and we have the denominators, okay, we have numerically, we have the coefficients 8, 24, and 27, and I'm going to kind of do a bit of an exercise. If you look at, say, the prime factorization, and you have for 8, we got 4 times 2. So 8 goes to 2 times 2 times 2. And with the number 24, for 24, you see we have a combination like 3 times 8. Now 3 is a prime number, and again, prime numbers are those natural numbers whose factors will be 1 and that number itself. And 4 we can factor out to 2 times 2. And you got times 2. And for 27, you have 3 times 9. And 9 in terms factorable to 3 times 3. Okay, and now for what we have in the case of the prime factors, okay, we have at 2 and 3. And the variable factors we have in x and y. And in the case of what we refer to as the least common denominator, So you're going to take the highest degree representation of 2 and 3 from what we have among the prime factorizations. Okay, so you have 2, it appears 3 times from 8, also 3 times from 24, and it doesn't appear at all from 27. So least common denominator. We have 2 times 2 times 2. And we have with the number 3, it doesn't appear for 8. It appears only 1 time for 24, but it appears 3 times from 27. And with x and y, you're going to go with the highest degree representation of the letters x and y. So we have an x, okay, that's going to be x to the 4th. And for y, we have y squared, y to the 3rd. And so for the least common denominator, we got 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 8 times 27, that would be 216. And with the variables, we have x to the 4th, y to the 3rd. So this is going to be the smallest term that all 3 of these will all go into. Okay, so we have, so in terms of raising the fractions, okay, so for 3 over 8x cubed, y to the 2nd, again, we're going to multiply by 1 the form of how much this will go into the least common denominator. So we got 216 divided by 8, so that will leave us with 27. X to the 4th over x cubed, that will be x. Y cubed over y squared, so that's going to be y. And for 1 over 24xy, taking 24xy into the least common denominator, okay, that's going to leave us with, looks like 9. X to the 4th is x cubed. And y into y cubed, that is going to leave us with y squared. And we have for 3 over 27 x to the 4th y cubed. And that first ratio could have been lowered, and I'll get to that in just a moment. Okay, so we have 27 into 216, that is going to be at 8. You have x to the 4th into itself 1 time, and y cubed into itself is 1 time. So just taking what we have now, okay, so you have 81 xy plus 9x cubed y squared plus 24, and we have all over 216 x to the 4th y cubed. Now, reduction could have been done with the last ratio in advance, but just for what we have collectively, we have out of the 3 terms in the numerator, we have the greatest common factor with 3. And guess what? With 216, 3 will go into 216 as well, so I'm just going to draw this out. So we have 3/3, 3 at the top, 3 at the bottom. And so for your final result, okay, so you have 27xy plus 3x cubed, y squared plus 8, and we have all over 72 x to the 4th times y to the 3rd.